Welcome back to my channel. Let's calculate the dimension of acceleration. I've dropped this video before. I checked the comment section. So many students are still confused on how to calculate or write down the dimension of acceleration. So that's why I'm making this video to explain in detail on how you can calculate the dimension of any quantity in physics. Okay?
Solution.
Before we continue, note that calculations under dimension is all about formulas. Okay, it's all about formulas. What you need to know is the formula of different quantities in physics. Know the formula of acceleration, velocity, and other physical quantities in physics. So once you know the formulas of various quantities in physics, then you can calculate the dimension of any quantity. Are you getting it? So what is the formula of acceleration? The formula of acceleration is what? Is velocity all over time, right? We are done with the first part. Velocity all over time is the formula of acceleration, right? So the second part, ask yourself, what is the formula of velocity? The formula of velocity is what? Is displacement. Displacement all over time. All over time over this time here. Displacement all over time is the formula of velocity, right? Divided by this time. So the next step to take is to multiply these two times together. Okay, let me show you how we come about this. We have displacement, right? Displacement all over time. We can also write it this form, that is time all over 1. I guess it. Either we write it in this form because this sign is a sign of what? Division. I getting it. So we have displacement all over time multiplied by 1 all over time. This sign of division will change to multiplication once the denominator come up and the numerator come down. Are you getting it? So this sign will change from division to multiplication. Are you getting it? So displacement times 1 will still give us displacement, right? Still give us displacement all over time multiplied by time will what? Give us time square or t square. Okay? What you should understand is that in place of displacement, you can also write it distance all over this time square. Okay, in calculating for various dimensions in physics, in place of displacement you can also put distance, the same thing. Okay, so when we are calculating for dimension, there is a rule. There are only approved 3 physical quantities used in writing down the dimension of every quantity in physics. Are you getting it? So those approved 3 quantities are length, mass, and time. Length, mass, and time. So these are the approved 3 physical quantities used in writing down the dimension of all quantities in physics. Are you getting it? So here we have to change everything in order to correspond with these 3 approved quantities. Okay, so we have distance here, right? So in the place of distance, we can change it to length, either distance or displacement. We can change it to length. Are you getting it? So we have L all over T square. Are you getting it? We have to change everything in order to correspond with these 3 approved quantities. Okay, so we have L all over T square, right? So let's draw a bracket, open and bracket close sign. We'll put these 3 physical quantities, which is L, M, and T, right? L stands for the symbol of length, M is a symbol of mass, while T is a symbol of time. So here we have L and T, but M is not present here, right? So since we have L here and L is the numerator, we represent it with 1. Are you getting it? M is not present, right? So we represent it with 0. Any quantity that is not present, you represent that particular quantity with 0. Okay? So T is present and also T is the denominator. You know how we do it? We put -2. You present the denominator with -2. 2 is here and also T is what? The denominator, right? So T is -2, L is 1, and M is not present. So we represent M with 0. Are you getting it? So in case you are asked to write down the unit of acceleration, from this formula, you can write down the unit of acceleration. This is a symbol of length, right? So what is the unit of length? Length is measured in what? Meter, right? All over. Why? The unit of time is what? Is second square here. So second square, or you can still write it this way: meter second raised to -2. See the same thing. Okay. So this is how to calculate for the dimension of various physical quantities in physics. It's very simple. Okay. These three quantities are the approved physical quantities in physics using writing down the dimension of any quantity in physics. Are you getting it? So if you find this very interesting, give it a like, drop your comments. Please share this video for other students to watch and learn. Thanks for watching. Follow for more videos. Bye.